Hi and welcome to today's video. So I'll be introducing three different techniques that you can use to differentiate different kinds of numbers in differentiation. I'll be introducing the chain rule, the product rule, and the quotient rule. I'll be explaining them in detail and I'll be giving you sufficient examples for you to have a better understanding of them. Alright, let's learn about these three rules in differentiation. Alright, so today I'm going to introduce the chain, product, and quotient rules. So the chain rule, product rule, and quotient rule are three techniques of differentiation in three different situations. So now there will be cases in differentiation where you will need the above three rules or the above three laws to actually make your work easier, and I'll show you what these examples look like. So some of these are not as straightforward as the numbers we've differentiated before, so these are gonna be very useful, but I want to encourage you before we even start off that they're actually easy and they'll be easy for you to understand, but also as a good gesture I'll also explain them to the best of my capabilities. Alright, so let's learn these three different techniques, but beginning with the chain rule. Alright, so the chain rule helps us differentiate composite functions. So mark that word, composite functions. So examples of values that are composite, so values like cos 6x. So in trigonometry, this may look like one of the double angles, for example, cos 2x and the rest. So those are examples of composite functions. As you can see, this may not be as straightforward as other numbers. Then now we have another example of a composite function where we have x squared plus 5 being in brackets and then to the power 10. So this is actually not as straightforward as the numbers before. So this kind of example will require chain rule. Then we also have another example of exponents where we have ex cubed, and that will actually require chain rule. Another example is cos x squared. So the chain rule states that dy over dx shall be equal to dy dt times dt dx. Now that will basically depend on the variable that we shall actually be using. So in case you make your in case in your chain rule you choose to let your value be equal to u or any other variable, so the t is actually flexible, so it may actually change depending on what you're actually dealing with in whatever situation. But for our examples, we're going to be majorly focusing on using the letter t. But I believe this will make sense as we do a lot of different numbers. So it's going to be a formula, and I will just encourage you to memorize that. Alright, so let's look at a question. So we're being told, given that y is equal to bracket x squared plus 7 to the power 100, find dy dx. So now this is an example that you can already clearly see requires the chain rule. So the first step we're going to do is we can already see that y is equal to that bracket x squared plus 7 to the power 100. So we're going to let t to represent the value inside the bracket. So we're going to represent this value inside the brackets using a different variable. So we're going to let t be equal to that value. So we can actually see that now when you differentiate this, now we're going to differentiate the t. So that's going to be, so we're going to present the two different variables. So we have a t and we have an x here. So we're going to have a dt dx. So now when we differentiate this, you can actually see that this becomes 2x, and because this is a constant, it becomes 0. So at the end we are left with dt dx being equal to 2x. And then we can actually see that now originally we were told that y shall be equal to x squared plus 7 to the power 100, but now we've chosen to represent this value here using a letter t. So now we're going to represent this using a t. So now we can actually say that y shall be equal to t to the power 100. So dy dt shall be equal to 100t to the power 99. So when you differentiate that, we're going to have the 100 coming to the left hand side of this variable t, and then we're going to subtract that index minus 1. So the index 100 minus 1, which is equal to 99. So dy dt shall be equal to 100t to the power 99. So from chain rule, we've just discussed that dy dx shall be equal to dy dt times dt dx. So now we already know that now dy dt is 100t to the power 99, and then dt dx is 2x. So when you multiply those, we can actually see that our dy dx shall be equal to 200x t to the power 99. But remember, originally we did not have a t in our calculation, so we're going to substitute we're going to represent that t by the value it actually represents. So remember that t is equal to x squared plus 7. So therefore dy dx shall be equal to 200x brackets x squared plus 7 to the power 99, and that's going to be our final answer. Alright, let's look at another question to actually understand this even much better. So given that y is equal to x squared minus x squared brackets power 42, find dy dx. So you can see that y is equal to that. So we're going to let t represent the values inside the bracket. So now our dt dx shall be equal to 7x to the power 6, as you can see, minus 2x. And then we can actually see that then y shall be equal to t to the power 42. So dy dt is equal to 42t to the power 41. And then from chain rule, we remember dy dx shall be equal to dy dt times dt dx. So when you substitute in those values, this is what we end up having. So now we have 42t to the power 41 times 7x to the power 6 minus 2x. And then we can actually see that this is what we actually end up having when we actually multiply the 2. But we remember that actually the t was representing x power 7 minus x squared. So therefore dy dx shall be equal to 42 into brackets 7x to the power 6 minus 2x bracket into another bracket x power 7 minus x squared to the power 41. And that's going to be our final answer for dy dx. Alright, so now the next example, we've been told that given that y is equal to sine 2x, find dy dx. So now this is an example of a double angle in trigonometry. And as we've said, this is also a composite function in this case, and it will also require the chain rule. So next, we're also going to let the t to represent this value here. So this is going to be different. We're going to represent the t. We're going to let the t represent the values right there. So t shall be equal to 2x, and then we can already see that dt dx shall be equal to 2. And then we remember that then y shall be equal to sine t. Now when we differentiate, so from derivatives of trigonometry, we know that the derivative of sine is cos. So dy dt shall be equal to cos t. So from chain rule, dy dx shall be equal to dy dt times dt dx. So now we have cos t times 2. So the answer shall be equal to 2 cos t. So the answer shall be equal to 2 cos t. But we remember that t is representing 2x. So that means dy dx shall be equal to 2 cos 2x. So now there is actually a trick that happens here that I actually want you to remember. So it's going to enable us solve these numbers that have trigonometric functions more easily. I've observed if you have an example of a composite function with in this case, so what happens is another shortcut to doing it actually in your mind to know the answer you're going to get to. So basically, first of all, know the derivative of whatever you've given. So whether it's a sine, a cos, or something, you actually just have to remember that. So the derivative of sine as itself is cos. Now next, you also look at this variable right there. So remember the t was representing 2x, and then you know that when you get the derivative of 2x, it shall be equal to 2. So now we're going to bring that 2 in front of the derivative that you actually get. So now the derivative you get from here, you actually just introduce it to the front. So that's how we have a 2 cos 2x. I thought I would just give you that as a hint so that you actually just have a quicker way to actually know if you're actually doing the correct thing. Alright, let's look at another question. So we're being told to differentiate y is equal to tan x squared. So this is also another example that requires the chain rule. So also we're going to represent this using a t. So we can actually say we're going to let t to be equal to x squared. So dt dx shall be equal to 2x. But y now is going to be equal to tan t. And now the derivative of a tan shall be sec squared. Now this is going to make more sense as we approach the section where we're going to be dealing with derivatives of trigonometric functions. But basically just take it as I've said it. So the derivative of tan t is sec squared t. So now from chain rule, dy dx is equal to dy dt times dt dx. So now we have sec squared t times 2x. So this ends up being 2x sec squared t. but t is equal to x squared. So now we end up having dy dx being equal to 2x sec squared x squared, and that's going to be our final answer. Now let's look at the product rule, and this is also going to be useful. So the product rule helps us to find the derivative of products of two or more functions. The product rule states that dy dx shall be equal to u dv dx plus v du dx, and that's going to be our formula for the product rule. Now this is just an example. So this is just a case where we have different functions that are actually multiplying each other. So when we have different functions multiplying each other, we use the product rule. So let's see some examples to understand this better. So in example number 1, let's look at an example that requires the product rule. So we're being told, given that y is equal to bracket x squared plus 1 bracket x cubed plus 2. So you can actually see now we have two different functions multiplying themselves. We have this and that. So now what someone else may have done is they would just open multiply the two different brackets and then get the values there and then differentiate directly. Now I would also agree with you that that would also work, and you would also actually get the correct answer. But now the product rule just gives you a better way, a better, quicker way to actually solve this. So now we're going to let we have y is equal to that. So now in this case we actually have two different variables that we're actually introducing, the u and the v. So now we need the u, we need the dv dx, and we need the v, and we also need the du dx. So what we're also going to do, we're going to always let the first value be equal to u, and we're also going to let the second value be equal to v. So now we're going to let u represent the first value or the first function among the products. So now u shall be equal to x squared plus 1. So now du dx shall be equal to 2x, and then we're going to let v to represent the other function. So now we have dv dx being equal to 3x squared. So now that we have this, we can actually substitute in all those values directly into our formula to get the value of dy dx. So where there is u right here, we're going to place that, and then where there is dv dx, we place that. Where there is then plus v is going to be this value into du dx, which is the value you get right there. So from product rule, this is what we have, and then when we substitute in the values, this is what we end up having. So this is the value of u times the value of dv dx, which is that, plus v, which is that, times 2x, which is the value of du dx. So when you multiply those, this is what we actually end up having. But every time we deal with product rule, it's better to actually simplify your function into the simplest form. So in this case, we can actually open the brackets, and this is what we end up having. So you have 3x to the power 4 plus 3x squared plus 2x power 4 plus 4x. And then when we can see that the 3x power 4 plus 2x power 4 will add, then we'll have 5x power 4. Then we can actually see that this is what we have as our final answer for dy dx, and that's how we use the product rule in this example. Alright, moving on to question number 2, we're being told, given that y is equal to x minus 1 times root x squared plus 1. So we're being told to find the dy dx in this example also. So how do we do this? So now this is what we have for y. So we're going to simplify this, state it in a better way. So now we know that the root here just represents power a half. Now this is a unique example because we can actually already see that now this other second function is now a composite function because it actually includes a power on a bracket. So now this is going to require a chain rule in this case. So in this case, we're going to mix product rule with chain rule, but let's see how that's going to work out. So first of all, we're going to let the u to be equal to x minus 1, then we can actually already get the value of du dx as being equal to 1. So now when we move on to the next one, we're going to let v represent the x squared plus 1 bracket to the power a half, but this case it requires the chain rule. So how are we going to do it? So you can actually see that v is a composite function, so therefore we find dv dx using chain rule. So now we're going to let t to represent x squared plus 1, and then dt dx shall be equal to 2x. So now v is therefore be equal to t to the power a half, and then dv dt is equal to a half t to the power negative a half. So from chain rule, remember that now Now this is going to be different because now we're going to simply use the chain rule to find dv dx. So since we're using the chain rule to find the dv dx, that means this vast value here is going to be a dv dt times dt dx. So it's just a change, a slight change of values. So now this is what we end up having. So we have a half t to the power negative a half times 2x, which is equal to xt to the power negative a half. But remember t is equal to x squared plus 1. So now therefore dv dx shall be equal to x into x squared plus 1 to the power negative a half. So now that we know what our dv dx is, now we can use our product rule finally. So now let's substitute in the values we found into our product rule. So now this is what we actually end up having. So now when we open, so when we multiply them, this is what we end up having. So this is how this can actually easily be expressed. But this is not the most simplified format. Now what we can see is the next thing is we can actually factorize out this x squared plus 1. So when you factorize out the x squared plus 1, so when you pull it out of brackets, so factorize out x squared plus 1 power negative a half. So you can actually see that inside the brackets we'll be left with x into x minus 1 plus x squared plus 1. Now this is very useful because you can actually see that now this x squared plus 1 is left with the power 1. And then once if we are in case we were to take this back, it will actually give us an x squared plus 1 to the power a half, because negative a half plus 1 is equal to positive a half. So now this is the best way of stating that. But remember that when we have anything, when we have any value to the power of a negative power, it actually means you can actually get the reciprocal of it and then make that a positive. So now this can be represented as 1 over x squared plus 1 over brackets power a half. Then right here, when we open these brackets to simplify, we can actually say that we have x squared minus x plus x squared plus 1. So these values cancel and we are left with, actually we can actually see that this value and this one add, so we have a 2x squared minus x plus 1. So now this eventually will show us that dy dx is equal to 2x squared minus x plus 1 over root of x squared plus 1, and this is the answer they wanted. Alright, so moving on to the next example. Now this is more unique. So given that y is equal to root of x plus 1 into x minus 2 cubed, find dy dx. So you can actually see that the y is given as that. So now everything is under the root, so that means everything has a power a half. So every bracket has a power a half attached to it. So this can actually be expressed this way. But now because we already have a power 3 on this bracket, so now we have a 3 times a half, which is 3 over 2. So now we're going to let the u be represented as x plus 1 to the power a half. But u now is a composite function, so that we find du dx using chain rule. So using the chain rule, we're going to let t be equal to x plus 1, so dt dx shall be equal to 1. Then we can actually see that now u shall be equal to t to the power a half, so therefore du dt shall be equal to a half t to the power negative a half. So from chain rule, in this case the chain rule is being used to find du dx. So du dx shall be equal to du dt times dt dx. So now we have a half t to the power negative a half times 1. So we have a half t to the power negative a half, but t is equal to x minus 1. So therefore du dx is equal to a half into x plus 1 bracket negative a half. The brackets actually to the power negative a half. So that's how we find du dx. Now when we also let v to be equal to the other composite function, you can actually see that v is also a composite function. So that we also find dv dx using the chain rule. So we're going to let t be equal to x minus 2, so dt dx is equal to 1, and then v shall be equal to t to the power 3 over 2. So you can actually say that dv dt shall be equal to 3 over 2 t to the power a half. And that's actually what happens in this case. And that's because 3 over 2 minus 1 is the same as a half. So from chain rule to find dv dx, you can actually say that we have dv dx being equal to dv dt times dt dx. So now we have dv dx being equal to 3 over 2 t to the power a half times 1, which is 3 over 2 t to the power a half. but we remember t is equal to x minus 2. So therefore dv dx it shall be equal to 3 over 2 bracket x minus 2 to the power a half. So now that we know what du dx is, we know what dv dx is, and then we know the u and v values, we can actually now use the product rule. So introducing those in, this is what we actually left with. So now this is what it actually looks like. So the next step is we can actually now factorize out. So actually I can already see there is a plus sign here. I can actually factorize out a half. I can also factorize out x plus negative a half, and I can also factorize out x minus 2 to the power a half. So when I factorize those two out, what I'm left with in bracket is 3 into bracket x plus 1 plus x minus 2, and this is what we actually left with. So now here actually I can already see that now, since this is the power to a negative a half, I can actually see that now I can actually take this down to the denominator and make that a positive. So now this is what will actually look like. So on this other side, when I open brackets, I have 3x plus 3 plus x minus 2. Now 3x plus x is equal to 4, and then 3 minus 2 is 1. So now I'm left with that. But now since both top and bottom here are to the power a half, that means I can put them all under the same root, and then I have a half outside. And then right here, remember we remained with 3x, we remained with 4x plus 1, and then this shall be the answer that we're actually looking for. So therefore, in the most simplified version, dy dx shall be equal to a half into root x minus 2 over x plus 1 times 4x plus 1, and that's going to be our final answer. Alright, so lastly, let's look at the quotient rule. So the quotient rule helps us find the derivatives of a function that is the ratio of two differentiable functions. The quotient rule states that dy dx shall be equal to v du dx minus u dv dx over v squared. So now the product rule deals with the product of two different functions or more. Now the quotient rule shall be dealing with the ratios. So that means two different functions dividing one another, and that's going to be the case. So let's look at an example that requires the quotient rule. So given y is equal to x squared plus 1 over x squared minus 1, find dy dx. So this is an example that actually requires the quotient rule. So we can't use the product rule here, and actually this one doesn't even require any chain rule. So this requires basically the quotient rule. But as if you can see in different examples, it's possible to have a chain rule within a quotient or product rule, and that will be okay. So in this case, we're going to let u to always represent the numerator value and v to represent the denominator value. So this is what we have as our value of y. So we're going to let u be equal to x squared plus 1. So therefore du dx shall be equal to 2x. Then we're also going to let v be equal to x squared minus 1. That means dv dx shall be equal to 2x. So from quotient rule, we can actually say that now dy dx shall be equal to that. So we're going to substitute in the values, and this is what we end up having. So let's simplify that. Now basically be careful in this case. Now as you can already see, I can already extract out the 2x. I can actually pull it out of brackets, and this is what you end up having when I factorize. So inside the brackets, we must be careful, because now this negative, when it multiplies the brackets, I'm left with a negative x squared minus 1. So that's something to actually watch out for, because in quotient rule there is a negative sign right here. Then you can actually see that now the v value, we shall always square that. So that's why we have x squared minus 1 squared. So as you can see, x squared minus x squared, that shall cancel, and then I have a negative 1 minus 1, which is negative 2. So that's why I have a negative 2 remaining in bracket. So negative 2 times 2x shall be equal to negative 4x. And then this is what I remain with as my final answer after using the quotient rule. Alright, let's look at another example. So now we're being told that given that y is equal to 2x squared minus x cubed over root of x squared minus 1, find dy dx. Now this is an example to be careful about, and that is because when I look at the denominator value, there is already a root. So that means this are actually going to be to the power a half. So that means there's going to be a chain rule somewhere when I actually deal with the denominator. Right, so let's look at this. So y is equal to that. So That means that at the denominator we can actually represent that as x squared minus 1 to the power a half. So I won't let u to represent the numerator value. So u shall be equal to 2x squared minus x cubed. So du dx shall be equal to 4x minus 3x squared. Then we're going to let v to represent the denominator value. So v shall be equal to bracket x squared minus 1 to the power a half. But v is a composite function. So there we find dv dx using the chain rule. I hope it's becoming clearer now when a chain rule is required. So we're going to let t be equal to x squared minus 1. So dt dx shall be equal to 2x. And then now v therefore shall be equal to t to the power a half. And then dv dt shall be equal to a half t to the power negative a half, which is equal to a half t to the power negative a half. So from chain rule, dv dx shall be equal to dv dt times dt dx. So now dv dx shall be equal to a half t minus a half times 2x. And then this ends up being xt to the power negative a half. But t is x squared minus 1. So that means dv dx shall be equal to x into x squared minus 1 bracket to the power negative a half. So from quotient rule now that we know what dv dx is, we know what du dx is, we know what v is, and we know what u is, so now we can use the quotient rule. So now in the quotient rule, we can now finally introduce that. So now simplifying the quotient rule, basically, so this is what we end up having. So now we're going to have to factorize out the x squared minus 1 to the power negative a half. So when you factorize that out, that is what we're actually left with in brackets. Now, basically, always be careful in this section when you're multiplying a negative into the brackets, because there will be a change of signs. So that's the most important thing to actually consider. And then, as you can see, when you look at the denominator, remember the denominator, it was actually a v squared. So when you square the v, remember that a half times 2 shall actually be equal to 1. So now at the denominator, we're actually left with x squared minus 1, and that's what I have right there. So now this x squared minus 1 to the power negative a half, since it's the power negative, we'll actually now take that to the denominator, and then we're going to have a positive. So now have a positive x squared minus 1 into a half, as you can see right there. But now basically these are identical, they actually have the same variable. So now we can actually add 1 to a half. So 1 plus a half is 3 over 2. So that's when we end up with x squared minus 1 being equal to the power 3 over 2. So at the numerator, when you open brackets, we are left with actually this value that we actually have right now. And then when we simplify that, we know that 4x cubed minus 2x cubed is 2x cubed. And then we can actually see that what else is similar? Actually, most of the other values are actually basically the same. So we have 2x cubed minus 4x minus 2x power 4. Actually, this and this are similar, as you can see right there. X power 4 minus 3x power 4 shall be equal to a negative 2x power 4. And then this is going to be our final answer for dy dx. Alright, so let's look at another question right here. So we're being told that given that y is equal to root x plus 1 cubed, and then at the bottom we're left with x plus 2, find dy dx. So now this is another example where we actually have to be careful with the steps. So now we can see that y is equal to that. So now let's change that root to a power. So now that means since the root is for both the denominator and the numerator, so that means we have a power a half multiplying the top and the bottom. So now since there is already a power 3 at the numerator, so we have 3 times a half, which is 3 over 2, and then at the denominator we know that they're already to the power 1, which is 1 times a half, which is a half. So this is what we are left with. Now this is an example that clearly requires chain rule for both the numerator and the denominator, as we shall see. But now let's first work with it. So now we're going to let u represent the value at the numerator. So u shall be equal to that, and then you can actually say that u is a composite function. So that we find dv dx using the chain rule. So we're going to let t be equal to x plus 1, dt dx shall be equal to 1, and then we'll know that u shall be equal to t to the power 3 over 2. So therefore du dt shall be equal to 3 over 2 t to the power a half. And remember from chain rule, to find du dx, du dx shall be equal to du dt times dt dx. So now we put in those values, we can actually say that du dx shall be equal to 3 over 2 t to the power a half. But we know that t is equal to x plus 1. So therefore du dx is equal to 3 over 2 into brackets x plus 1 power a half. So now we're also going to let v represent the denominator value, so v shall be equal to that. So v is also a composite function, so therefore we find dv dx also using the chain rule. So we're going to let t be equal to x plus 2, dt dx shall be equal to 1, and then v shall be equal to t to the power a half. So therefore dv dt shall be equal to a half t to the power negative a half. So from chain rule, dv dx is equal to dv dt times dt dx. So therefore dv dx shall be equal to a half t to the power negative a half times 1. So now therefore we have a half t to the power negative a half, but t is x plus 2 in this case. So therefore dv dx shall be equal to a half into x plus 2 power negative a half. So from quotient rule, we're going to substitute in the values, and this is what we end up having. So basically observe a denominator, a half times 2 is power 1, and that basically remains with the power 1. Then this is what you actually end up having in a more simplified version. So now this is what we end up having. So now we're going to factorize out a half, then we're also going to factorize out x plus 2 to the power negative a half. Then you can also factorize out x plus 1 to the power a half to actually simplify that better. Then inside the brackets we're left with 3 into x plus 2 minus x plus 1 over x plus 2. And then you can actually see here that now since this is the power negative a half, we can actually change that and take it to the bottom. Then this is actually what we are left with. Then when we open these brackets and multiply, we have 3x plus 6 minus x minus 1. And then right here, this is actually what we are left with. So now right here, it's clear that we'll be left with 2x plus 5 for these values right there. But now everything here is actually dividing this value right there. And you know that when we divide everything at the bottom, it's the same as multiplying this 1 over that, and this is what we should end up having. So now it shall become 2x plus 5 into x plus 1 power a half over 2 into x plus 2 to the power 3 over 2. So now this can actually be represented this way. So now we actually have two different values that actually have a half in them. So we can actually put this and this together, and then this shall be represented this way. And then on the other side we are left with 2x plus 5 over 2, and then this is how we represent it in the most simplified version, and that is what they wanted. Alright, so after all the numbers we've actually worked out on, to get better at whatever I've just explained, I encourage you to actually differentiate the following and then work on to get the answers that I'm actually displaying for you right here. So just compare your answers to what I actually have here to actually see if you're on the right track. So now remember that it is practice that makes perfect, or as I would say, practice makes permanent. So if you do these examples and you're able to solve them and get the answers I'm giving you right here, I believe you've actually understood the chain rule, the product rule, and the quotient rule. So basically, thank you for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.